Hey, the topic today, evaluating finding limits analytically, specifically limits at infinity. This corresponds to section 4.5 in our textbook. This is a topic I really like because I like how it's easy to visualize. Just kind of look at the problem holistically, make a determination. So let's jump right in. Example 12. The limit as x approaches infinity of 5 minus 2 over x squared. So kind of look at each piece on its own to start with. The 5, the 2 over x squared. So let's start with that fraction, 2 over x squared. X is getting bigger and bigger and bigger. So 2 over 1 squared, 2 over 2 squared, 2 over 3 squared, 2 over 10 squared, 2 over 100 squared, 2 over 1000 squared. As x gets infinitely large, the overall value of the fraction gets smaller. So 2 over 100, 2 over 1000, 2 over 10,000. That fraction's overall holistic value is approaching 0. Now again, will it ever be 0? No. But calculus is not concerned with what a function is. It's concerned with what it's approaching. So 2 over x squared is approaching 0. We can effectively cancel it out. And then we're left with the 5. Just 5, no x. So as x gets bigger or smaller, doesn't matter. It's just 5. And we have our answer. If you remember, in algebra and pre-calculus, you looked at horizontal asymptotes. There were 3 cases. You would have to compare the numerator of the degree of the numerator to the degree of the denominator. If the numerator was bigger, there was no horizontal asymptote. If the degrees were equal, the horizontal asymptote was the ratio of the leading coefficients. If the denominator degree was larger than the numerator, then the horizontal asymptote was 0. So you can look at these algebraically, kind of what it is, and evaluate it for how it looks. Or you can use the calculus viewpoint and say holistically, what is the behavior? What is happening? What is this function doing? Example 13. Again, kind of look at the problem holistically. So the top 2x minus 1, the bottom x plus 1. Now let's look at the top first. Imagine someone says, hey, you just won, I'm going to give you $1 trillion. But that's not all. I'm going to double it. You're getting $2 trillion. But just wait, there's more. I'm going to take $1 away. Kind of realistically, are you upset about that $1? You already have 2 trillion. For free, they gave it to you. Now they want 1 back. It's not really significant. In this case, now there's the minus 1. Now look at the denominator. Hey, I'm going to give you $1 trillion. But just to make your day, I'm going to give you 1 more. Now you already have $1 trillion. And you get 1 more. I mean, that's positive, but it's not really significant. You're already $1 trillion there. What's 1 more? So the plus 1 is the denominator. Also really not significant if x is really, 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 really big. So you're left with 2x over x. Cancel out the x's. And you just have 2. So again, you can do these algebraically with those cases, or you can look holistically at the problem. Why did I do that? Okay, so example 14, let's kind of work through those, just kind of be holistic about it. So the first problem, example A, the plus 5, the plus 1 don't really matter. X in the top, remove an X in the bottom, and you're left with the limit as X approaches infinity of 2 over 3x. So you have 2 on the bottom, a number that's getting bigger and bigger and bigger and bigger. That overall fraction is getting smaller and smaller, going towards 0. Okay? Example B. In the top, the plus 5 doesn't really matter. The bottom, plus 1 doesn't really matter. So you have 2x squared over 3x squared. Those x squareds cancel out, and you just have 2/3. Example C. Again, that plus 5, that plus 1, not really significant. There's an x cubed in the top, x squared at the bottom. We can take away 2 of those x's. So you're left with the limit as x approaches infinity of 2x over 3. So kind of going the other way, you can see it there, okay. So going the other way, you have the numerator getting bigger and bigger and bigger and bigger and bigger. The denominator is just 3. So then, if your fraction overall is getting infinitely large, infinity is not a unique value. So the limit does not exist. Or if you're really kind of pressured to give more information, you can say it's getting infinitely large. So you're approaching infinity. If you have to, a better answer is D&E. But if you have to, you could give more information by saying infinity. Now, all of these examples deal with approaching positive infinity. Let's go ahead and look at a case where it makes a difference if you're approaching positive or negative. So let's kind of zoom in a little. So first problem, 3x minus 2 over root 2x squared plus 1. Alright? So first, let's start by getting rid of insignificant values. Minus 2. I got an alarm going off. Stop that. Okay. So minus 2. And then the plus 1 and the square root. Not really, plus 1 is already insignificant. You're going to square root it. Still pretty insignificant. So we have the limit as x approaches infinity of 3x over, now look at the denominator, square root of 2x squared. Let's go ahead. Let's take the square root of that, alright? Because square root 2x squared is the same as root 2 times root x squared. So let's evaluate that square root. Root 2 is root 2. Root x squared is x. So now we have an x top and bottom. They cancel out. And you're left with 3 over root 2. And here's the nice thing. On the AP exam, you don't have to rationalize fractions. So you can leave it as 3 over root 2. If you want to, go nuts. Just make sure you do it the right way. If you take a right answer and make it wrong through your work or simplification, you'll lose the points. So if you can leave it as a square root denominator, go ahead and do that. Now let's look at example B with a negative infinity that x is approaching. So same start, minus 2 plus 1 limit as x approaches negative infinity. Now you want to be careful because that x value, you're going to be substituting in a negative value, or they're getting more and more negative. So it's a 3 and a negative x. It's a root 2 and a root negative x squared. Let me write that. Alright, it is important to realize that. In the first problem, example A, x was positive, didn't really matter. You didn't have to worry about it. In example B, the negative matters. So you have to consider it as you're working. So limit as x approaches negative infinity of 3 negative x over root 2, and then do some mental arithmetic. Negative x squared becomes positive x squared. Take this square root. The negative has gone away in the bottom, but it's still in the top. So when you cancel out common terms, that negative value in the top remains in the top. The top retains the negative, or the negative remains, but then the bottom is gone. So your final answer, negative 3 over root 2. So as you're working through these, it's important to see getting rid of anything that's insignificant, but then as you're approaching positive or negative infinity, does this sign matter in the course of the problem? You have to address it where it's appropriate to address, where there will be a significant change on the problem.